So suppose I have a charge, now I'm giving values. So suppose I have a charge of 3 microcoulomb at a point minus 2 comma 0. Everything is in meters. Okay, this is x-axis, this is y-axis, everything is in meters. There's a charge at point minus 2 comma 0, and all charges are fixed, let's say this charge is fixed. Now find the work done to bring a charge of 6 microcoulomb to a point 5 comma 0 from infinity. Find the work done in bringing a charge from infinity to the point 5 comma 0. So let's say this point is A, this point is B. Find work done to bring a charge (6 microcoulomb) from infinity to point B. 18 K by E, because there is 9 into 10 power 9 in the,
Yes, sir.
right?
Yes, sir.
Okay. Now, next question is a continuation of this question. So, write this as 1I and second one is double I 2. Okay. So, next question is find work done to bring a charge 6 microcoulomb from point B to a point. So I'm bringing this charge only, not any new charge. Same, this 6 microcoulomb I am bringing from point B to point C, and point C has a coordinates of 0 comma 2.
Well, like how much charge does it have?
Same charge, 6 microcoulomb.
The point at the point C.
So what am I doing with 6 microcoulomb? From B, I am taking it to C. So how much work is done by an external agent? We have to find.
Yes, sir. I mean, distance, we take it as hypotenuse.
Should I solve it? Or okay, give it a try. Distance we will take as the hypotenuse, AC.
Sir, we consider electric potential energy like from infinity to that point. So here, it's at a certain point, so we can't use that formula.
I will solve it. Okay.
Sir, is it like you're bringing from infinity to that point C, and you're bringing from infinity to the point where it's 6 microcoulomb, and you find the net of it?
That is correct only, but too much of English. I don't know that much English. Let me solve it. See, we defined the potential energy of the system as the work done to bring that point charge from infinity to this point, right?
Yes, sir.
Now, with that particular definition, I can say the potential energy of the system initially is equal to, we already found it, it was 18 into 10 to the power minus 12 K by 7. We just did that, right?
Yes, sir.
Correct. Similarly, the potential energy of
But
this,
it is like 18 into 9, so 162 by 7.
Yeah, we can do that, but I'm okay. The
Okay.
potential energy of the system finally, when the charge is at point C, is equal to, in the only difference is denominator will become 2 root 2 because AC is 2 root 2. Correct?
Yes.
Clear?
Yes, sir.
Now, work energy theorem is what we have discussed in the last.
Rate of change in uh, potential energy, electrical potential energy.
Yeah, you are right, but wrong also. Don't get attached to things like that. Try and follow it up thoroughly how I explained it. Okay, it's a simple story. You give me 5 bananas, I have 5 bananas. That's the story. Okay, so energy always is better to look at it as a scalar and understand it that way. What I'm trying to say is, suppose when the charge is at B, the system has 7 bananas.
Yes, sir.
When the charge is at C, if it has 10 bananas, that means I have given 3 bananas.
Yes, sir.
Or suppose initially that when the charge is at B, the system has 7 bananas. And when I shift it to point C, it has 4 bananas. That means I have taken 3 bananas.
Yes, sir.
Story is simple. So, in the earlier case, from 7 if it goes to 10, work done by me is 10 minus 7.
Yes, sir.
Or in the other case, if it goes from 7 to 4, then also work done by me is 4 minus 7, which is minus 3.
Yes, sir.
What we are trying to say is that work done by me is going to be the final potential energy of the system minus initial potential energy of the system, because we are keeping the kinetic energy change to be 0.
Yes, sir.
In fact, exactly 0. Okay, clear?
Yes, sir.
So simply the answer to this is work done is equal to that 18 into 10 to the power minus 12 into k is going to come as a common thing, and final minus initial 1 by 2 root 2 minus 1 by 7. This is my answer.
Yes, sir.
Is this clear?
Yes, sir.
Take it down.
I was thinking right, but I was scared if I
Too
was
much English. Yeah, too much. As I told you earlier, physics has its own language. If you identify the difference, it becomes very easy. Life becomes very easy. Now, in the next question, there is a square of side A, small a. Square is A, B, C, D. At the vertices A and B, we have 2 point charges, small q.
Yes, sir.
Question is, when there is a third charge Q1 placed at C, find the potential energy of the system due to the charge placed at Q1. Find the initial potential energy of the system.
Like we bought Q1 from infinity.
Yes.
Yes, sir. And Q and Q are fixed.
Are fixed, but they will also have a potential energy of themselves.
Yeah, sir. I mean, for this case.
For this case, yes.
So should I tell in terms of variables? A, yes, sir. I put in variables. I put P1, P2. And P1 is nothing but K, Q1, Q by.
U1, U2, potential energy.
Yeah, sir.
IP, we write P1, P2. Yeah. Good habit. Okay, fine.
Yeah, sir.
Second question. See, now understand, or I'll just give you the question. Okay. Second question is find the. So, first question was find the potential energy of the system. Now, find the work done to bring Q1 to point from infinity to point C. Find work done to bring Q1 from infinity to point C.
Yeah.
See, find work done to bring Q1. So that means we have Q and Q at A and B fixed. Now we have to bring Q1 from infinity to point C. So find work done to bring Q1 from infinity to point C is nothing but the part of potential energy that is only related to Q1. That means I have to not consider the potential energy of Q and Q.
You basically added two potential energies at 2020.
That's it, right? So the
Yes.
idea is that the reason why I wrote this first and then this is now in this term, this is the potential energy between A and B, and this is the potential energy between AC and BC. Correct?
Yes.
And
Yes.
and now if I have to bring a charge Q1 from infinity to C, how much work will it be? The work it has is the same as this particular quantity, this much.
Yes, sir. Yes, sir.
Here?
Yes, sir.
No. So, like you wrote yesterday, up to date you will finish off today, so you will not have any problem. Okay, don't be much bothered because I am also not much bothered. Now, third question in the same thing, third part. Find the work done to take this charge from point C to point D. Find work done to take this charge, take Q1 from C to D.
Sir, it will be the difference of this thing and the potential energy when we take it to D.
Correct.
Won't it be the same? It'll be zero.
Good. So because of symmetry, work done will become 0.
Yes, sir.
Now, fourth question. This you'll have to solve. So, find work done to take the charge Q1 from C to midpoint of CD. Midpoint of C. That means this is A by 2. Find the work done from taking Q1 from C to midpoint of CD. Hello everyone. Welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG, and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video.
Sir, take Q1 Q by A of 1 plus 1 by root 2 minus 2 by root.
Okay, so let us see. See, I already have the potential energy of the system initially. Now I only have to find the potential energy of the system finally. Right?
Yes, sir.
First term will be the same because the charges are in the same position A and B.
Q1 Q.
Now Q and Q.
Q
Now,
means Q, why did you write Q square?
Q into Q will become Q square.
We are taking it between of Q and Q1.
I'm saying the first term, KQ square by A, potential energy between these two.
We have to take potential energy between A, B, and C, and A, B, and the midpoint.
We have to find the work done to take the charge Q1 from point C to the point that is midpoint of CD.
Third, initially the work done was KQ1Q of 1 by A plus 1 by A root 2.
We have nothing to do with the previous stories. Why will we have anything to do with the previous stories?
You calculated the work done, no, sir.
We have work done due to second one, third one. We can have more and more work done. Fine. Nice.
I'm telling that it will be. Yes.
That is great. I felt very good. I am saying to find the work done to take blah 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 blah. How should I solve?
We join from the midpoint to A and B, and the distance from there will be A root 5.
Just now I explained to you here in the previous question. Work done, we will just write it as the change in energy. That is, initially I have 5 bananas. Finally, I have 10 bananas. So work done by me is equal to 5 bananas.
Yes, sir.
Now, what you are saying, work done to bring charge Q1 from infinity to point C, it is not wrong. But I am saying, why do you want to go somewhere else to do something?
Sir, I'm telling, like, that is nothing but the potential energy only, right?
Potential energy of what?
From bringing the like Q1 from infinity to C.
We can say change in potential energy.
That is that thing minus 0. It's nothing but the same thing. That's why we can.
What is 0?
I mean potential energy at the infinity. That's why work done is this one.
That's why question number 2 is different. Question number 4 is different. Infinity is 0. At point C is so and so. We got the answer.
Yes, sir.
At infinity, the potential energy is 0. At point C, the potential energy due to Q1 in this system is this. So work done is this. Great. Why do I have to think about infinities now?
I told it for second question. This question, the initial point will be C, the final point will be the midpoint. So we take the difference between the potential.
Final minus initial.
Yeah.
Simple. Clear?
Yes, sir.
So thing is, we just have to get used to these situations. Nothing difficult in it. But always we will apply the work energy theorem, right? And best part is it is a scalar. So basically all I have to think of is how much energy of the system has increased or decreased or what has happened. 2 apples became 5 apples. That means work done by an external agent is 3 apples. 2 apples became 0 apples. That means work done by external agent is minus 2 apples. Right?
Yes, sir.
Now, understand how I am explaining fourth bit. Okay, fine.
Yes, sir.
Find the work done to take the charge Q1 from point C to the midpoint. Correct?
Yes,
If you
sir.
look at the third one, from point C to point D, you told me initial energy and final energy are the same due to symmetry. So that means I am assuming you were trying to do subtraction of final energy minus initial energy.
Yes, sir.
Therefore, you got 0. Here also we will do the same thing. Subtraction of final energy minus initial energy.
Yes, sir.
So what is initial energy? We found it in first bit only. KQ square by A is due to A and B, and KQ1Q into 1 by A plus 1 by A root 2. Fine?
Yes, sir.
Now I only have to find the final energy. Right?
Yes, sir.
What I was saying in the final energy is that because Q and Q are in the same position, they will remain the same, KQ square by A energy.
Yes, sir.
The first term will remain the same. Only the second term will change. This term will change, correct?
Yes, sir.
So potential energy due to Q and Q1, Q and Q1, they are symmetric. So I can say 2 times, right?
I think I went wrong in the first one. I think I'm getting confused because of that.
You
I
will today.
went wrong. I
Today
didn't get the first term, I guess.
didn't get the first term.
Yes, sir.
AQ square by A.
Yes, sir. And why
In the
is that?
first, see,
Because you asked the potential energy of the total system.
of the system means system.
Yeah.
Now you don't have to ask if it is total system or system. It's system. So
Yes, sir.
whatever is there in the system, that is. See, the difference between the first bit and second bit was in the second bit we did not have this term.
Yeah, sir.
So I wanted to show you that in the first bit we are trying to find the potential energy of the system initially. Okay?
Sir, could you show how you did?
How?
You did it.
The first bit?
Yes, sir.
See, this distance is A.
Yes, sir.
This distance is also A.
Yes, sir.
Hypotenuse is A root 2.
Yes, sir.
Now, potential energy between these two, potential energy between these two, and potential energy between these two. Potential energy between A and B is
But
KQ.
why are we considering the total potential energy in the fourth question then?
In the fourth one.
Yes, sir.
So, is the first one clear?
Yes, sir. You're taking potential energy between everything.
Between everything. Is the second one clear?
Yes, sir.
That means in the difference between first one and second one is this fellow. The potential energy of these two, we have nothing to do with that in the second bit. Okay. Work done to bring Q1. What does it have to do with the potential energy between A and B? They will anyways be the same.
It should be between AC and BC.
AC and BC. That's why this term came into picture, right?
Yes, sir.
This is my second. Clear?
Yes, sir. Yes, sir.
Third bit is find the work done to take Q1 from C to D. So there you identified that the symmetry, everything is in fact the same. So the change in energy is going to be 0.
Yes, sir.
So initial potential energy and the final potential energy are the same. So here we can say initial potential energy of the system and the final potential energy of the system are the same. So the change is 0. Therefore, the work done is 0. Right?
Yes, sir.
Now, to solve the fourth one, work done to take Q1 from point C to midpoint of CD.
Yes, sir.
Initial potential energy of the system is already there in the first bit.
Yes, sir.
All I have to now extra I have to do is final potential energy of the system.
Yes, sir.
What is the final potential energy? In the final potential energy also, the A and B potential energy will remain the same. They haven't moved. It is
Yes, sir.
KQ square by A.
Yes, sir.
What has changed is the position of Q1 has changed, right?
Yes, sir.
The new position is actually symmetric from A and B.
Yes, sir.
So potential energy due to A and this Q1 and B and Q1 will have same values due to symmetry. Distances are the same.
Yes, sir.
How much is this distance? A root 5 by 2. Height is A and this horizontal length is A by 2.
Yes, sir.
So it becomes
4.
root 4 is 2.
Okay, yeah, yes.
Okay.
Yes, sir.
So now we got the distance. We have symmetry. A and Q1, B and Q1 will have same potential energy. That's why I'm writing it as 2 times.
Yes, sir.
Times of what is the potential energy between A and Q1? A Q1Q divided by distance is what? A root 5 by 2.
5 by 2.
This 2 will go in the numerator. It will become 4.
Yes.
So the final potential energy of the system is KQ square by A plus 4KQ1Q by A root 5. Correct?
Yes, sir.
I told you 2 apples, 5 apples. What is the work done? 5 minus 2,
5 minus 2.
3 apples. So here also, what is the work done? Final potential energy of the system minus initial potential energy.
Yes, sir.
Clear?
Yes, sir.
Final potential energy minus initial potential energy. The first term will anyways cancel.
Yes, sir.
So now I'm going to write the second term. 4KQ1Q by A root 5 minus KQ1Q to 1 by A plus 1 by A root 2. This is my work done for the fourth bit. Is this clear?
Yes, sir.
Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.